Some AI models generate tens of thousands of invisible words before they ever answer you. That silent process is called a reasoning chain, and it's rewriting what these systems can do. Hi, I'm Mira. Today we're pulling back the curtain on internal reasoning chains, the hidden loops where models draft, check, and correct their own logic before you see a single word. This is how thinking models compute logic without human input, trading a single guess for a private cycle of drafting, critiquing, and revising, all before the final answer appears. A prompt enters, but the real work happens in a hidden scratchpad you never see. The model checks its own logic against the goal, and only then commits to the final answer. Each hidden cycle runs the same 4 stages. First a draft hypothesis, then a critique hunting for flaws, then a revision patching the logic, and finally a commit once the answer holds up. Your prompt is visible, and the final answer is visible. But sandwiched between them is scratchpad reasoning. Hypotheses, checks, and revisions the model runs entirely out of sight. Let the model take more reasoning steps and accuracy climbs steadily, from 55% at a single pass toward 88% after 32 internal steps on hard math problems. A researcher pulls up a raw reasoning log and watches the model compute an answer, spot an arithmetic slip, and quietly rewrite its own logic before replying. No one prompted the fix. Standard prompting uses 0 hidden tokens and scores 42%. Add chain of thought prompting and accuracy rises to 61. A native reasoning model spending 3,000 hidden tokens reaches 83. On a hard math benchmark, a direct answer scores just 13%. Prompted chain of thought jumps to 41. A model built to reason natively hits 83. So far we've seen that hidden reasoning boosts accuracy. Now let's look at the loop that makes it self-correcting. The loop is simple but powerful. Generate a step, verify it against constraints, and if it fails, revise and retry. Only a step that passes verification gets committed to the final chain. This is test-time compute scaling. Spend 100 hidden tokens and get 50% accuracy. Spend 100,000 and approach 90. Thinking longer behaves like a dial the model turns itself. On the hardest questions, some models silently generate 50,000 tokens of reasoning, an entire hidden essay of trial, error, and correction, before you see a single sentence of the reply. Self-verification takes several forms. Majority voting samples many reasoning chains and keeps the consensus. A verifier model scores each step independently. Backtracking abandons dead ends and retries from an earlier point. This autonomy isn't flawless. Hallucinated logic looks confident, but is false. Looping wastes compute, repeating itself. And overconfidence means the model skips verification, letting errors slip through unchecked. An engineer sets an AI agent loose to debug a codebase. Over dozens of hidden reasoning cycles, it forms a hypothesis, tests it, fails, revises, and fixes the bug, without a single new instruction. That accuracy isn't free. An instant reply takes 1 second, light reasoning about 6, and deep reasoning up to 40 seconds. The price of letting the model verify itself before speaking. Recursive self-correction means one human prompt now spawns its own sub-goals, critiques, and iterations, a loop that runs on the model's own compute with no further human steering. This shift means less prompt engineering, since models plan their own approach. It means emergent multi-step planning without instruction, and it means a new surface to monitor. Errors now hide inside hidden reasoning. This is the shift underneath it all. Raw next word prediction turning into active deliberation, where compute becomes the mechanism for checking, doubting, and improving an answer before it's spoken. Remember 3 things. Hidden scratchpads do the real work through draft, critique, revise, and finalize. More reasoning steps raise accuracy. and self-correction loops run recursively without any new prompt from you. That's the hidden architecture behind thinking models, compute turned into deliberation. Next time, how these reasoning chains can fail silently and what that means for trust. See you then.